This lesson is an introduction to trigonometric ratios. So we'll be talking about trigonometry, and we'll be thinking about ratios, the comparison of two numbers. You will be learning about the three trig ratios: sine, cosine, and tangent. Now we abbreviate these three trig ratios with their first three letters. Sine looks like this. We don't say sin, we say sine. When we say cos, we say cosine. When we see tan, we know that's tangent. And the acronym, the memory device that can help us remember that sine is the opposite side over the hypotenuse. Cosine, the adjacent side over the hypotenuse. And tangent, the opposite over the adjacent, is SOHCAHTOA. That helps us remember these three trig ratios. So in a right triangle, you'll be looking at some acute angle in that right triangle. And we'll either be finding the sine of that angle, the cosine, or the tangent. And we're going to be writing a ratio of 2 of the 3 side lengths. So we'll get started with this 30, 60, 90 right triangle. And in this right triangle, which you've studied before in this unit, you know that there's a relationship between the side lengths. You know that if you have the short leg length, the side opposite the 30 degree, then the hypotenuse is double that. And you know that the longer leg is the short leg times the square root of 3. So with that in mind, to find the sine of 30 degrees, sine is the opposite over the hypotenuse. So the opposite side is 1 and the hypotenuse is 2. So the sine of this 30-degree angle in this triangle is 1/2. So remember, in this 30-degree angle, the sine was 1/2. Cosine of 30 degrees. Well, cosine is the adjacent over the hypotenuse. The hypotenuse is definitely 2. The adjacent side to this 30-degree angle is the square root of 3. So for this triangle, the cosine of 30 degrees is the square root of 3 over 2. And the tangent of 30 degrees is the opposite, which is 1, over the adjacent, which is root 3. So keep that in mind. And let's look at another 30, 60, 90 right triangle, but one with different side lengths. So now we have different side lengths. Instead of the short leg being 1, the short leg in this case is 5. What is the sine of 30 degrees? In the case of this triangle, the sine of 30 degrees was 1/2. All right, so sine of 30 degrees. Remember, sine is opposite over hypotenuse. So it's 5, that's your opposite. And we want to think about what is our hypotenuse. Well, let's think about our relationship with the 30, 60, 90. This one is definitely 60, right? If you remember, we have our MCAS reference sheet. And down at the bottom, we have our 30, 60, 90. If we know the short side length, the side opposite the 30, then the hypotenuse is double that. And the long leg is the short leg times root 3. So with that in mind, this hypotenuse would be double the short side length. So the hypotenuse would have to be 10. And this base, this longer leg, would be the shorter leg times root 3. So now that we have our 3 sides, let's go back to figuring out the sine of this 30-degree angle. Sine is opposite, which is 5, over a hypotenuse, which is 10. But I'm looking at this ratio and I'm realizing 5/10 simplifies to 1/2. And I'm remembering on the other example, the sine of the 30-degree angle on the smaller triangle was also 1/2. So keep that in mind, okay? Cosine of 30 degrees. Cosine is adjacent over hypotenuse. So here's our 30-degree angle. The hypotenuse is definitely 10. The adjacent side is 5 root 3. And then I look at this fraction, I realize I can simplify this fraction because this coefficient 5 and this denominator 10, we can divide those numbers by 5. So this fraction simplifies to square root of 3 over 2. So my trig ratio for the larger 30, 60, 90 right triangle for cosine is still the square root of 3 over 2, just like it was here. So I'm guessing that the tangent of 30 degrees is going to be 1 over root 3. Let's prove that, okay? The tangent of 30, tangent is opposite, which is 5, over the adjacent, which is 5 root 3. And I'm realizing there's a factor of 5 here in the numerator and denominator. Let's divide both numbers by 5, and we get 1 over root 3, exactly as we expected.